screen. Thank you to our fantastic talent and workforce readiness teams who arranged for this event, as well as our top leadership who has taken time from their busy schedules to speak with you today. They are eager to give you a glimpse into the work that they do. Northwell Health is New York State's largest private employer with 61,000 employees. We currently have 21 hospitals, 4 skilled nursing facilities, 450 ambulatory and physician practices, and much, much more. We are not just a healthcare provider, but an integrated health system, which includes Care Connect, our insurance arm, a medical and nursing school, Northwell Ventures, which allows us to bring our discoveries to market, and we have the world-renowned Feinstein Institute for Medical Research. We hire approximately 250 people per week into over 6,000 different job titles, and we want you to think about Northwell Health when you think about your career. Top Minds Meet is an opportunity to share the exciting work and commitment to excellence from some of our top leadership. The format for today is we will have 4 esteemed presenters who will speak for approximately 20 minutes. After each presentation, you will have the opportunity to ask them questions through the chat function, which you will find on the bottom right corner of your screen. Today's session will be recorded, so if you would like to review the presentation, it will be available on our Northwell Health career website on the student page in the Career Conversations section. Today's webinar should be up on our site January 2nd. Right now, however, we have the Deputy Executive Director of North Shore University Hospital, John Sendak, who is responsible for operations of the 812-bed tertiary care hospital. His responsibilities include day-to-day non-clinical operations, oversight of facilities and ancillary services, as well as the hospital's trauma, emergency, and transplant programs. Please welcome John Sendak.
Hi, good morning, everybody, and thanks so much for having me. So I hope my audio is working okay and that you're able to hear me. And I'm going to go ahead and kind of take us through, for about 15 minutes or so, some of the examples of sort of my career progression, and then talk a little bit about some of the options that we have. So in no particular order, one of the things I say to college students often in my conversations is, we're in healthcare, we're a very, very, very varied and diverse industry. There's a lot of opportunities for folks, whether it's direct patient care, whether it's the business side of things, whether it's sort of the technical part of what we do, whether it's research, or any of our various services that support the organization. There's a lot of opportunities. Personally, I'll talk a bit about the role that I have, and I'll tell you a little bit about sort of how I've progressed through the various phases of my career. When I was going to college in the late 90s, for me personally, it was very important to be involved in healthcare. It's something that I was always very interested in, and something in many ways that was kind of challenging to figure out what the right on-ramps are to this industry. I spent my junior summer doing an internship here at North Shore University Hospital here in Manhasset, and I really enjoyed it. I loved the opportunity to work on the business side of healthcare. I knew from my time in college that clinical care was probably not going to be my forte. And so as a political science and French double major, I made the decision to try and pursue the administrative side of things. And yet when I got back to school in the summer before my senior year, late summer, it was very unclear through the career options, how do you get into this industry? What entry-level type roles are available for those college students that are not interested in being a nurse or a physician or something like that? And so that was kind of how, I made the decision that I needed to figure this out one way or another. In the end, I ended up not getting into healthcare right out of college. I graduated from Colgate University in upstate New York which is a small liberal arts college, toward the end of the 90s. And I initially began working for a public relations and marketing firm that had a worldwide presence, but I emphasized in their health and medical practice. So I spent 4.5 years working specifically on, mostly on clients that were healthcare providers, hospitals, health systems, some pharmaceutical companies. And I had the opportunity to learn the business through the consulting portion of healthcare. And it was a great entree. It wasn't ultimately what I wanted to be doing, but it was a great entree. And so what happened was, and I'm just going to try and click, hold on 1 second. And it won't let me advance the slide. So what I did was I focused more increasingly on the business focus of healthcare organizations, which then led me to get very interested in health policy and management. And I actually stopped working and then went to graduate school in New York City. I went to NYU, and I spent probably 2 full years going to school full time, learning about not so much the industry at that point, but about health policy, how the government sets health policy, and then a whole period of time in my second year on management and leadership. And following graduate school, I applied for and was accepted into a fellowship program, which many large health systems have across the country, for graduating master's students to spend 1 or 2 years in a residency or fellowship learning about healthcare management and healthcare administration. And I was fortunate enough to do that at the corporate offices of what was then the North Shore Long Island Jewish Health System, now Northwell Health. And following that began my executive roles in finance. And I spent 7 years as the chief financial officer at a few of our hospitals. I was at 3 of our community hospitals over 7 years, and then came to our flagship campus in 2009 as an executive taking care of operations. And 2 years ago, rose to the position of deputy executive director, which essentially places me as the second in charge of this hospital. Now, this particular hospital is about 850 to 900 inpatients, all the services that you can imagine in a major medical center, including solid organ transplant. We're a major trauma center and emphasize on complex neuroscience and complex cardiac, both surgery and interventional type procedures. Incredibly challenging environment to work in, very exciting place to be. And for myself personally, I will share with you that I have found the trajectory over the last 15 years to be extraordinarily rewarding. And I think that that's a big part of what happens when you get the opportunity to work in a number of different areas and then have the ability to figure out kind of what the next step is. Now, what I'll share with you about on-ramping programs and what I speak to students about quite often is the fact that we as on the industry side have to continue to find opportunities for interested college students to get into our organization, even though they may be coming from college with limited experience. And that's not something I found in the late 90s. What I found in the late 90s was you had to go out and get some kind of experience on the outside, and then the hospital would talk to you in 4 to 5 years. But that's not the case any longer. And so that makes a huge difference for us, which is now the ability to be able to figure out what the appropriate opportunities are for folks. And so what I'm going to do briefly is just share with you a couple of the programs we have. I spoke about myself, so we're going to skip through this and sort of what I did and take you to some of the programs that we have now that might be of interest to students. And so the first is our healthcare management program. Our healthcare management program is a 8-week paid summer internship for college juniors. And it's extremely competitive. We get hundreds of applications each fall for ultimately about 20 spots across what was originally just at this main hospital, but now exists system-wide. And so a great opportunity to apply to a program that gives you the chance to spend 8 weeks working in one of our facilities as part of a cohort in a program that really allows the connection between college juniors and the industry. And we find this to be probably one of our best opportunities to expose students to this business and give them access to the management teams of our facilities and business units, so that they can kind of feel their way out and understand what opportunities would exist upon graduation. At the end of that summer, we encourage all of those who were here for the summer who are interested in potentially coming back to talk with us about careers on graduation. The program structure, the internship, is being teamed up with mentors, excuse me, working with executive leadership, meaningful hands-on project work, lots of time to tour the different facilities, sitting in on meetings, and really having an opportunity to spend time with other young people who are at a similar place in their journey. It's extremely experiential and extremely hands-on. And the photo that's on the screen now, you'll see 3 of our interns taking a tour of our helicopter, Sky Health. So just a great opportunity for students who think they might be interested in the non-clinical side of healthcare. Some project examples: efficiency of hospital operating rooms, the utilization study of interventional cardiology and EP labs, working on a philanthropic concert, working on annual reports, looking at physician utilization cost effectiveness, doing business planning around major capital purchases, and understanding some of the new governmental payment systems that are coming as part of the Affordable Care Act, and whatever we may see over the next few years. So here's a picture of last year's cohort with their preceptors, and just a great example to take college juniors that are interested in taking them through that. Our entry-level program for graduating seniors is called the Management Associate Program, and this is a 2-year, not an internship, 2-year job. In the first year, we spend a lot of time on project management and doing analytics, managing people, emotional intelligence, and then the second year we move into the advanced application, which is figuring out how to work more with the medical staff, driving innovation projects, working with our off-shift supervisors that run the hospitals at night and on the weekends, and actually learning how to become a mentor themselves to first years. So it's kind of a freshman, sophomore kind of arrangement. At the end of the second year, we hope that those folks are ready to continue on with their career journey. These types of programs are things that I, as a 21-year-old in the late 90s, had really hoped that hospitals would have, because so many other industries did, and they were really pretty non-existent. I looked all over. And so one of the things I've personally been very interested in is creating these kinds of programs so that summer interns can then turn into employees, and so that students that are midway through their college education can say, hey, I might be interested in this. This is the kind of internship I want to apply for. And so we have the Healthcare Management Program, which is our summer internship, and then we have our Management Associate Program, which is our entry-level first and second year onboarding. This is just an example of the kind of curriculum that we have for, again, graduating seniors for their first and second year. And much like a college transcript, we kind of keep track of all the experiences that our management associates have in their first 2 years to make sure that everyone's getting the same well-rounded experience. And 2 of the people on the site side that work with these programs with Cheryl's team over at Talent Acquisition and Workforce Readiness are listed here, and certainly the contacts that you have through Cheryl's group are always available to answer questions from any student about what kinds of programs do we have at Northwell Health that would be of help. But these programs, for me personally, emanated from my now 13 or 14 years of being in executive positions in hospitals, and recognizing the kinds of talent that we need. And so any opportunity we have to talk with college students that are considering what we do as a career, we're always more than happy to talk to and provide guidance. So that's all I have in terms of content in my 15 minutes or so. And so if we'd like to open it up for questions, I'm certainly happy to take them. So I have a couple questions that have come to me through the chat. So I'll go ahead and take those questions. The first one is what are the opportunities for experienced hires in graduate schools? And the answer to that question is the graduate school programs in healthcare administration are varied throughout the country. There's a number of degrees. We call it the alphabet soup of healthcare administrative programs and degrees. Some schools offer Masters of Public Health, MPHs. Some offer MHSAs, Master of Health Services Administration. Some have MHA, Masters of Healthcare Administration. Some have MPA, Master of Public Administration. There's MBAs, Master of Business Administration in Healthcare. And the list kind of goes on. And what I would tell you is that most of the programs will take students right out of undergrad. Many of them prefer students that have 3 to 4 years of work experience. But they're not as strict as the MBA programs typically have been over the years with saying we only want people with work experience. Experienced hires that go back to graduate school do extremely well. I'm actually a faculty member at NYU. I teach one graduate school class in the master's program at NYU each semester. And I would say about half my class are just graduated from undergrad, and about half my class is experienced people in the workforce in New York City or the surrounding areas who are going back to school, much like I did. So I think it's a mix. So something just to be mindful of in terms of what are the opportunities for experienced hires in graduate school, which is the way the question was. I think that the opportunities are pretty extensive. I was one who, quote unquote, was an experienced hire. I worked for 5 years, went back to school, not uncommon at all. The second question is, when will the management associate program be open for applications? And the answer is beginning after the first of the year. You'll start to see more information about it. What I should note is that we do fill many of our management associate spots from our summer internship from the previous summer. So many industries do this. The summer interns get first access while they're here. Many of them interview at the end of the summer for the graduation period of time. And so some of the positions for MAP are already filled, but there are still some that will be open, and there will be more information available on our website after the first of the year. So the next question is the internship paid? And if so, how much? Yes, the summer internship is paid. In terms of how much it is from an hourly rate standpoint, I don't know the exact hourly rate figure. That's more of a human resource question, but we could probably follow up with you specifically. What if you're currently in grad school and need flexible part-time internship or job? If you're currently in grad school and need flexible part-time internship and job. The flexible part-time job question is a good question for our folks over at Talent Acquisition. I'm not sure how that works, but what I will tell you is that we have many employees that are working in healthcare because of the nature of the way healthcare jobs are scheduled who are going to school full-time. I personally worked full-time and went to school full-time, and I think that that's pretty reasonable. And the last question I will take, we probably won't get to all these, but we do have to get to our next speaker, is the program available for graduates of all majors, including engineering, which is also a question related to another question, which is, what if people are going to the senior year of nursing school? And the answer to the question is, yes, we look at people from all majors. So that's very important. I personally am a graduate of a liberal arts school. I got into finance very early on in my healthcare career. We are not limiting these kinds of jobs to accounting majors or any of those things, because the types of skills we need to be successful managing large-scale healthcare organizations are people that have numerous backgrounds. So we are not limiting them to any majors. But the follow-up question was, what about students that are going to their senior year of nursing school? And my recommendation on the nursing school is that externships in nursing are much more valuable for people that are going through their BSN programs than a program like this. The summer internship for healthcare management are typically for people who've ruled out clinical care. but rather want to focus on the non-clinical management of the organization. Because to excel in nursing leadership or most of the clinical leadership, you'll have to have a number of years in clinical practice. And so it's important to get that phase of your career out of the way, spend a number of years, and then if you want to transfer over into management, it's not a problem. Many of our senior leaders in this organization are nurses by training who've just since stopped practicing. But having a nursing degree and having not practiced might cut you a little short. So I would strongly recommend nursing externships. And so not to cut into Dr. Tracy's time too much further, and I apologize because I see there's a list of other questions here that we're not going to have a chance to answer. What I will say to you is through Cheryl's group in Workforce Readiness or through Robbie Graber or Adam Becker, whose names were just before up on the slide deck, please feel free to email them directly and they will be happy to answer any of your questions related to either of the two programs, and any way we can help students figure out what are they interested in and what would they like to do, we're happy to do. So I'll pass the baton now over to either Cheryl or Dr. Tracy, and thank you very much for tuning in today.
Okay, well, welcome back, and we are very excited to have our next speaker present. Kevin J. Tracy, MD, is President and CEO of the award-winning Feinstein Institute for Medical Research and Professor of Molecular Medicine and Neurosurgery at the Hofstra Northwell School of Medicine. He is a leader in the study of molecular basis of inflammation. He and his colleagues identified the neural mechanism for controlling the immunological responses to infection and injury, and developed devices to replace anti-inflammatory drugs in clinical trials of rheumatoid arthritis, a new field termed bioelectronic medicine. Dr. Tracy delivers lectures nationally and internationally on inflammation, sepsis, the neuroscience of immunity, and bioelectronic medicine. Please help us welcome Dr. Kevin Tracy.
Hello. Nice to meet you all over the internet. What I thought I would do for a few minutes is explain to you what the Feinstein Institute is, and then talk about possible careers in science. And if there are questions and you want to send me specific questions of things you'd like me to cover, go ahead and send me a message as I'm speaking. So the Feinstein Institute is the home for research at the largest health system in New York called Northwell Health. The research operation here has 4,000 people doing research and 1,000 students. The laboratories here are home to research in immunology, study of the immune system, and neuroscience, study of the brain and the spinal cord. We also have significant expertise in cancer research in collaboration with our clinical colleagues in the Montra Cancer facilities here at Northwell. We have a large clinical trials operation. This includes 1,200 clinical studies that enroll almost 20,000 people a year into clinical research. And we have work in health outcomes research, which looks at how patients are treated following their medical records, following their treatment protocols. In order to really understand recommendations for treating patients in a big population, you have to really understand how the current therapies we have and we use are how effective they are, and that's called health outcomes research. So in this research operation of this 4,000 people doing research in the hospitals and in the laboratories at the Feinstein Institute, we also have a lot of opportunities for students. We have medical students and college students and graduate students. The medical students at the Hofstra Northwell School of Medicine spend a lot of their time in the clinics, but they also spend time in the laboratories. And in the summer, we have an internship program for high school and college students. The application for that is online. The interns come in, as I said, from mostly college, but some high school students and some medical students. and they work in the laboratories or in the clinical departments doing clinical trials for the summer, and this is a tremendous educational experience. And we also have education for our faculty. So a life in science and a life in research is a life of continuous learning. One of my favorite definitions of research is that research is the process of inventing the future. Another favorite definition of research for me is Albert Einstein's definition. Albert Einstein said, if we knew what it was we were doing, it wouldn't be called research, would it? And when you put those things together, what you have is you have researchers are lifelong learners. They're constantly learning something new in order to make predictions about the future. And so that's where we are. That's what we do here at the Feinstein Institute at Northwell. And for the students and people thinking about research careers or science careers, I thought I would just explain that there's really a couple of different routes to having careers in science. One route after high school and college is to go to medical school. A lot of medical school graduates, a lot of doctors practice medicine, of course, but many don't. Many doctors practice medicine for a couple of years after medical school, and then decide that they're really interested in understanding that they want to do research on actually making new drugs, not just give out the drugs that have already been made by other people. And for those people who decide to pursue careers in science after medical school, there are many, many options for working in laboratories or working in companies as postdoctoral fellows and postdoctoral trainees to develop those careers in research. The other option after college to do a career in science or research is to get a PhD, is to go to graduate school and get a PhD in one of the fields of science. It could be chemistry, it could be biochemistry, it could be molecular biology or immunology. There are literally hundreds of different specialties that students can, after college and graduate school, get a PhD in a scientific specialty. And these PhD scientists can run laboratories. They can actually work on very sophisticated medical problems. You don't have to go to medical school to work on medical problems and research. And the career path for those individuals can be to stay in research as professors at universities or medical schools, or to move into industry, in the pharmaceutical industry or the biotechnology industry, to work in science in those on the industrial side. And a third route to science, which people don't usually think of or talk about, is to pursue engineering. Engineering, you can major in engineering in college, of course, and there are postgraduate degree programs in engineering, there's master's programs, and there's PhD programs in engineering. Now, engineers, a simple definition of an engineer is someone who learns how to build things. And engineers can build software, they can build computers, they can build cars, they can build airplanes, they can build molecules. There's chemical engineers, electrical engineers, civil engineers. And of course, these opportunities for engineering are increasingly now intersecting with careers in science and medicine. Technology being built by engineers is increasingly being used in the hospitals, in the operating rooms, and increasingly technology is being implanted into patients. Small devices and medical technologies are being developed by engineers in collaboration with scientists. So as a neurosurgeon, I'm a neurosurgeon that has studied immunology for 30 years. As a neurosurgeon interested in immunology, I am now working regularly with engineers as we develop inventions for new devices to target the nervous system, to make these devices to be used instead of drugs. And so that's what I thought I would share with you today. And an introduction to the Feinstein Institute, an introduction to sort of career paths in science, and I'd be happy to take any questions if anybody wants to type them in.
We do have some questions for you. The first is, what is the most innovative project that you are currently working on?
Right now, we're working on a project to build devices, electronic devices, that are implanted into patients to control a nerve to the spleen that's called the vagus nerve. And by sending electrical signals into this nerve, it's possible to turn off inflammation in these patients. And that's been really exciting because we did a clinical study of this idea in Europe, and we showed that patients with rheumatoid arthritis, a very severe, debilitating form of arthritis, could be cured by, not by a drug, but by implanting this device, which turned off inflammation and made these people feel better. And this idea, this most exciting idea that I'm working on is called bioelectronic medicine.
We have another question. Can you please explain how 3D bioprinting works? 3D bioprinting.
So, no, I'm not an expert on 3D bioprinting. I can tell you that the excitement of 3D printing is in biology right now comes from combining the proper substrates, the proper matrix, the proper tissue components, so that you can reconstruct an organ in the lab and then implant the organ into an animal or a patient. These 3D printers essentially work by depositing one layer at a time, very thin layers, all of the components in that individual layer. If you think of an orange, if you were to slice an orange in very, very thin slices from top to bottom, you could reassemble the orange by putting the slices back together, one on top of the other. That's how a 3D printer works. It prints each individual slice. And so 3D bioprinting is developing the methods necessary to basically reconstruct living cells and living tissues, and there's a huge amount of work going on that now. There's a question on this webinar chat. Can you talk a little bit about your career path and how you got to where you are now? So my career path is I went to medical school at Boston University after graduating from Boston College. And then I trained, after medical school, I moved to New York and I trained to become a neurosurgeon at New York Hospital, Cornell University Medical Center. While I was training to be a neurosurgeon, in the course of this 10-year period, I would take a year or two at a time and work in the laboratory to be trained how to be a scientist. And so I did 4 years of college, 4 years of medical school, and 10 years of neurosurgery and scientific training. And the combination of neurosurgery and scientific training led me to what I'm doing now, which is a neurosurgeon who runs an immunology laboratory to study how nerves control the immune system. As the laboratory got really big about 20 years ago, I became interested in building research units that would not just be shared by my lab, but would be shared by many labs. And that led to me being the president of the Feinstein Institute, which currently, as I said in the beginning, has 50 laboratories and 4,000 people working in the 20 hospitals. There's another question. What's the best way for engineering students interested in medical device design to gain useful experience in their undergraduate years and internships? Engineering students can do summer internships and clerkships in medical school laboratories and in university laboratories that actually study biological problems. And I think that's a really important insight for engineers interested in medicine or medical problems. Engineering is incredibly important as a specialty to learn how, for instance, an electrical engineer learning how to build electrical circuits. But if you want to study medical problems, engineers should take some time in their career training to learn some biology and to learn some medicine. And there's a lot of ways to do that by working in medical or biology labs at medical schools and universities. Some of the most important engineering projects of the future are going to be done in collaboration with medical researchers or biologists. So I think that concludes my time.
Thank you so much, Dr. Tracy, for your insights. We very much appreciate your sharing them with us.
Thank you very much. Goodbye.
Our next speaker is Dr. Joanne Gottridge. Dr. Gottridge serves as Executive Vice Chair for the Department of Medicine at Northwell Health, the Associate Professor of Medicine at the Hofstra Northwell School of Medicine, and actively practices primary care general internal medicine as a member of the Northwell Health Physician Partners. During her 36-year tenure at Northwell Health, Dr. Gottridge has held various leadership positions in the Department of Medicine, including primary care and internal medicine residency program director and division chief for general internal medicine. Dr. Gottridge has been the recipient of the Sandra Atlas Bass Award for Clinical Excellence and the Tia Monte Award for Outstanding Community Education. Please welcome Dr. Joanne Gottridge.
So thank you very much. I apologize, I have a cold. Hopefully I can be heard. And thank you to the audience for joining us today. I was asked to describe a little bit about my career journey and then take any questions. I'll say that my career was largely unplanned, other than in the most general sense. When I went to college, excuse me, I liked science very much, but I wasn't exactly certain what career path that would take. I got the idea to go to medical school from my then boyfriend, now husband, who was pre-med. He took a different path, and I decided that medical school seemed like a good fit. I was fortunate enough to get in. I loved medical school. At that time, I determined the best course for me would be to be a community practitioner, and aspired to go back to my roots where I grew up, which was on Long Island. So when I was searching for a residency program and decided on general internal medicine, I found what at the time was a Cornell associated program based at North Shore University Hospital in Manhasset, with rotations at Memorial Sloan Kettering Cancer Center. When I finished the 3 years of medicine training, which I loved, although very different than training nowadays, and I looked at practice opportunities, I was very turned off by it. Different than now, there were very few women in practice, almost none in the Long Island community. And the way that practice was in those days, we're talking about the 1980s, you had to kind of earn your way by taking a fair share of abuse and low pay. And I had the offer to stay at North Shore at the time to help develop a primary care track of the internal medicine residency. I thought I would do that for a year or so and then go on to practice. And as was said in the introduction, I'm in my 37th consecutive year of employment at Northwell. I stayed because I've had a wonderful experience, and Northwell is an absolutely amazing place with an amazing number of opportunities, a very dynamic, ever-growing, ever-changing, kind of cutting-edge place. So I've been very fortunate to get involved in a lot of different things. So even though I've been here for 36 years, I've been fortunate enough to get involved in a lot of different things. I probably was known, as in the common parlance, as a clinician educator. Dr. Tracy talked about clinician researchers, of which we have many. But another track for clinicians is to be a clinician educator, to do clinical work on your own, but focus your other efforts on education of both postgraduate trainees in residency and fellowship and medical students. So I was for a while the primary care program director. Then I became the program director of the internal medicine residency at North Shore University Hospital in the period before it merged with LIJ to form what is now the Hofstra Northwell Internal Medicine Residency Program. And we had affiliations with Cornell, as was mentioned. We had affiliations with NYU, and we've been very fortunate for the last 5 or 6 years to have our very own medical school, the Hofstra Northwell School of Medicine, and I've been fortunate to be involved in activities with that. The clinical work, I'm a primary care general internist. I was fortunate enough to be able to develop a de novo practice affiliated with North Shore that now serves about 35,000 people. We've done a lot of work of outreach for uninsured and underserved populations and had some grants for primary care outreach. I also was involved in developing the hospital medicine program at North Shore and then overseeing the same activities at LIJ. And more recently have moved into more of an administrative role, overseeing with a team the community-based practices that are part of our medical group, which is known as Northwell Health Physician Partners, as well as some hospital operations and strategic initiatives for our service line, the medicine service line. I'll say a few things. Although I've been very fortunate to be involved in a lot of things that have been successful, there have been, as everyone has their shares of missteps or mistakes. I would tell you all as young people, although the mistakes feel the less pleasant than the successes, you can learn the most from things that don't work out well, as long as you're open to it. I will also say that I've been fortunate enough to be involved with and try many different things. Not all those things always worked out, but I'd encourage you all to be open-minded and do that. I think you can both find opportunities that are good niches for you and your efforts, as well as it helps you learn the things that you may not be suited for or may not enjoy. I'd say in summary, if any of you are thinking of going into medicine, I would tell you to please do it. I thank whoever, whatever, every single day to have gone to medical school and be a doctor. I think it is the greatest profession that you could ever have. Again, you're always going to have a job. There's a shortage of physicians everywhere. It is a great career. You have now the ability to have multiple career paths through getting an MD, as Dr. Tracy mentioned. You can do pure research. You can be a clinician researcher. You can be a clinician educator. You can be in administration. You can be in public health. You can be in informatics, et cetera, et cetera. It's a phenomenal career. And you're doing something that's extremely fulfilling and gratifying and helping other people in whatever capacity you serve. So I would say to go for it if you're considering it as a wonderful, wonderful profession. I would also hope that all of you can find as great a place to work as Northwell. As mentioned, this is a place with, tremendous expanse and opportunity, cutting edge, ever growing, ever changing, with a lot of opportunities. So I envy all of you. You're at the beginning of your journey. I'm closer to the end. And again, I thank you for joining us. I wish you all best of luck and happy holidays, and I'm happy to take any questions.
Do have a question for you. There is interest in hearing more about the residency program.
We have an outstanding, now one of the top programs in the United States. The individual who is the program director now is Dr. Karen Friedman, who was one of the residents when I was the program director at North Shore. She's also the vice chair for education in our service line. We have about 150 some odd residents in 3 years of training. We draw people from all over the United States, so we really have a nationally recognized program now. The two hospitals that the residents rotate through equally are North Shore University Hospital and Long Island Jewish Medical Center, both the major tertiary healthcare institutions in the system. The clinical rotations are outstanding. The faculty is outstanding. The quality of the students that we've been able to attract are outstanding. We have This past year, we interviewed 600 people for what will be 35 slots in the upcoming match. We had 100% American Board of Internal Medicine passage rates for our most recent residents taking the boards. And 100% of our senior residents applying for fellowship training got placed in fellowship positions. So we have an outstanding training program, again, nationally recognized, has really come up in the ranks, and we have outstanding outcomes from our graduates.
We have another question for you. It is, what do you see the role as a primary care physician in the future?
So that's an interesting question. I mean, I've loved being a primary care physician. The challenge is that we have a shortage of primary care physicians. And I think we're trying to be very innovative in our own health system, and there are a lot of innovations going on across the country. I think what's recognized now is the need for really team care that used to be that the doctor had to do everything. We're looking at what are called now patient-centered medical homes. We're looking for our primary care sites to be these patient-centered medical homes, or PCMHs, where we're integrating at the practice level behavioral health specialists, nurses, nurse practitioners or PAs, case managers, and where we're looking to do a better job of data management and assessment. So it may be appropriate for very healthy people who come in once a year for a routine physical or sick calls, common colds or sore throats, may be seen by a nurse practitioner or PA, and internal medicine trained physicians or family medicine trained physicians take care of the more complex patients, so we can better use our training and expertise. So I think there's going to be a lot of evolution of primary care. I think we're at the infancy of changing the model as it has existed, and I think there's a need to do so.
Okay, we have one more question. As someone extremely interested in being a clinician educator, what can we do now as college students to begin down this path?
That's a good question. I would say, there's nothing that you have to do to certainly, other than what you're going to do to try to be successful in college. But I think, if you can do some volunteer work, whether that be community work or at a hospital. I had done some shadowing of my doctor in the community or in an emergency room in a local hospital. I mean, it might just give you a better idea of what healthcare is all about. But, honestly, the path is, to get into medical school, and that's going to depend, not only on your grades and your MCATs, but, your total CV. So I think certainly any community-based work or whether it's related to healthcare or not, certainly speaks a lot of your sort of commitment to the community or mankind, and any opportunities to get closer to any clinical work, might be interesting or helpful.
We have one last question. What do you like most and least about being a physician?
I mostly like the relationship that I have with my patients. Again, I've been at this for a long time. I'm primary care. I have patients that I've known and cared for 34 years. You may have both the husband and the wife, and then they send you their kids and their extended family. I have probably most enjoyed the relationships I've had with patients. And, the root of the word for doctor has to do with learning or education, and really you learn as much from your patients as you educate them. So that would be the top thing. The least would be some of the bureaucracy and red tape and hoops that insurance companies have thrown in the way that you need to do to take care of your patients. That can be very frustrating sometimes. So, an example would be getting a pre-authorization. Most recently I had to spend a fair amount of time on the telephone multiple times to get a patient something that they need. That would be the least. I think a lot of that is going to be changing in time. But I will say, in the end, you say to yourself, if this is what I need to do to get my patient what they need, then that's what I need to do. But that would probably be the least enjoyable component of any doctor's day.
Appreciate your insights and sharing your expertise with us. Our next speaker is, we actually have two speakers. We have John Langone, who is the Vice President of Biomedical Services, and Mark Eisenbraun, who is the Assistant Vice President for Biomedical Services. John Langone is responsible for defining and implementing standards of practice system-wide with the proper care, maintenance, and asset tracking of all medical devices used in the care, treatment, or diagnosis of patients. This responsibility includes developing strategies for more efficient, cost-effective solutions of service coverage, support, and workflow strategies for all such assets across Northwell Health's hospital, ambulatory, and physician network. Mark Eisenbraun is currently the Assistant Vice President of Centralized Biomedical Services. Mark's knowledge of biomedical engineering comes from over 30 years' experience in the field. His accomplishments start with serving in the U.S. Air Force for 6 years, specializing in encryption and coding. Soon after, Mark started his career with Northwell Health as a Level 1 biomed technician. He spent 10 years as director of the Biomedical Engineering Department at Long Island Jewish Medical Center before assuming his new role. Please welcome John Langone and Mark Eisenbraun.
Good morning, all, and happy holidays to all. Thank you for the opportunity to speak with everyone today. I hope to provide you some interesting information pertaining to Northwell's approach to biomedical engineering services. I'm joined, as was mentioned earlier, with my Assistant Vice President, Mark Eisenbraun. Mark has 30 years of experience, both as a biomedical engineering technician and as a leader of biomedical service divisions within the health system. Our division is only about a year old. It's important to remember that and what our goal is to be that corporate focus and standardized body to create standardization and provide efficiencies and identical service delivery. And you'll hear a lot about those terms as we continue through these presentations. Can you please advance the slide? So what is biomedical engineering? Biomedical engineering is also known as clinical engineering and more recently as healthcare technology management. And it's the employment of specially trained individuals dedicated to the evaluation, care, maintenance, and upkeep of all clinical devices or equipment systems used in care, treatment, and diagnosis of patients. And just like all of our other colleagues, can you please advance? Patient care is our highest priority. And just like all of our other colleagues and those that have spoken earlier, as healthcare technology changes and improves and advances, biomedical engineering must keep pace. We've seen an evolution over the past 50 years in technology used in healthcare delivery, from more simplistic mechanical devices to electrical engineering managed required devices. And now, as information technology starts to really make an impression in healthcare delivery, electrical information technology engineering has become a bigger part of what we do, sort of the melding of all of the sciences. So those of you out there that are interested in electrical engineering, business, healthcare administration, information technology, we'll touch on all of these and what we do here as a centralized organization, as well as what is done boots on the ground at the hospital and physician offices. So the job titles that you should become familiar with if you're interested in this field are biomedical engineering technician, certified equipment technicians, biomedical equipment technicians. And those usually go from levels 1 through 3. And specialties within this realm include certified laboratory equipment specialists, dialysis technicians, and for really high-end imaging equipment, diagnostic imaging specialists. So, really, when we speak about medical devices, it's a very wide scope. A tongue depressor can be thought of as a medical device. It actually is a medical device. It's used in the care and treatment of patients. However, for biomedical engineering, we're dealing primarily with, as I mentioned earlier, those mechanical medical devices requiring calibration, requiring preventative maintenance, powered by some source, and oftentimes linked to other devices to make a system of devices to deliver care and treatment. So we're talking about anything ranging from a simple blood pressure device, which is known in our field as a sphygmometer. It took me about a year to learn how to say that properly. That goes all the way up to more sophisticated, minimally invasive surgical devices like robotics and extremely powerful imaging devices such as CAT scans, MRIs, magnetic resolution imaging systems, linear accelerators, which is used in the treatment of cancer. Please advance the slide. So our mission is to support the health system's missions actually and commitment to providing the highest quality of care for its patients. For biomedical engineering, that means ensuring the availability of safe functionality of all medical device technology through the collaboration with hospital technology, our purchasing division, and our service line care teams, all of whom work with us to make decisions on what is the next medical device that we're going to be moving towards through this entire evolution. Can you please advance the slide? As I mentioned earlier, we're a relatively new division, and we're providing oversight and creating standardization of practice of service delivery. Service delivery refers to the strategies we employ to utilize our resources in responding to specific or ongoing service events related to the service, upkeep of medical equipment. So our current state, or what I would say is earlier this year, before we really started getting our arms wrapped around the system as a whole, or Northwell, is that we had various service delivery models. That means that we've had sites that predominantly do most of the service and maintenance of equipment on site using in-house highly trained resources. We have locations that utilize third-party vendors to provide all of their services. We have insurance companies supporting some sites in what's called an insurance model. They basically cap your expenses. And then we have partnerships between third parties and internal resources, everything in between. So again, when you have variation where you can have standardization, that presents the opportunity for enhanced efficiencies, standardization, quicker response, and open, having what we had up until now, while everyone was safe, and I want to stress that all of our patients were always completely safe, and all of our sites were keeping up with their regulatory responsibilities. But when I say that there's an opportunity in the current model for inefficiencies and limited transferability of resources. I mean, just in terms of how quickly we could respond and how we can take resources from one site, move them to another site, even temporarily or in an emergent situation, to fix a piece of equipment rather than going to a third party. We can fix it faster, quicker, cheaper, and have the equipment available for our patients. So for future state, if you could please advance the slide. So that means that we're moving towards that standard service delivery model. Our goal is to be majority in-sourced, which means we use our own in-house resources to respond to the vast majority of requests across the entire paradigm of medical devices. We are moving to one standardized computer maintenance management system across all of Northwell, and that's across all hospitals, and that is across all physician practices. The benefit of that is we will be able to look in one computer system, run reports, check to see horizontally across all organizations how many defibrillators do we have, or how many MRIs do we have, what are the service contracts that we have on them, who's providing the service, and when was the last preventative maintenance, have we addressed all recall issues. And you'll hear a little bit later, the newest thing that we're going to be dealing with is how to manage potential cybersecurity threats. So to do this, we're in strong collaboration with our procurement division and our clinical services to define standards for all medical devices. The system and the new process will provide us with measurable outcomes that will give us the ability to then give back to the sites predictive modeling and a unified process and system tiered opportunities and continuous process improvements. For example, speaking to biomedical engineering technicians and their leadership at sites, they've requested for a number of years that they upgrade a particular device or group of devices or class of devices. However, they have to put in a capital request, and it comes up against other requests for purchases of high-end devices or other investments the health system needs to make to stay on top. It's always beneficial to present your business case with hard evidence that a device or a group of devices is costing you more money to maintain than it would cost to purchase a new device. So we look at the total cost of ownership of all devices. So if you could please advance the slide. How do we get from current state to future state? Well, as I mentioned earlier, it's about asset management, but what we are conducting is a full physical equipment asset audit. Actually, beginning January 3rd, the day we all come back from the holiday, we are going to begin with teams going through each one of our hospital and physician sites, validating their current inventory against what is seen and found on the floors, in the corridors, in the storage rooms, across the health system, to validate that, yes, that device is there, yes, it's being maintained appropriately, transferring that information. Please advance into this new technology platform. Again, that one consolidated computerized maintenance management system, allowing us the real-time reporting and what we call key performance indicators, which are the metrics that are going to help drive decision-making. Service delivery model, and that's the transition of all fully outsourced biomedical service to an insourcing model, which is currently underway, and then aligning the resources of all the other sites that are currently staffed within the hospitals to a standardized process of service delivery. That means that they have identical resources and skills within those resources to address what their site needs, or that we have the resources deployed to those sites at a moment's notice internally to address needs as soon as possible. Standard operating procedures. We've established monitors and we're establishing monitors and managing standards to best practice across the entire health system. We have utilized the expertise of third-party consulting companies and also reached out to colleagues across the United States and internationally that have taken this route to ensure that we are doing things appropriately, that we will get to that point of being quote-unquote best in class or best in breed And we're confident that we will be able to get there with the knowledge that we've accumulated across the health system in a very expedited fashion. We've developed a unified medical equipment management plan, and that's essentially your overarching policy to ensure that you're keeping abreast, you're keeping up with all regulatory authority requirements when it comes to maintenance, upkeep, management, and reporting of all medical devices. To do this once again, we're working on equipment purchases, the standardization of what types of devices and what manufacturers we're going to buy them from. As a non-for-profit health system, we do not partake in the exclusive purchase of a particular product or products. However, if we can limit that pool, it makes the training, transferability of knowledge, and maintenance costs all much more manageable, and that will give us more leverage in service contracting. So that requires strong collaboration with purchasing and clinical decision makers, and we will continue to support them by providing that meaningful reporting and that our system will yield, and by forging strong vendor relationships. Can you please advance the slide? So, meeting the challenges, both current and future. As I mentioned earlier, you can bring the whole slide down, that's fine. Cybersecurity. Cybersecurity, as most of you, I'm certain, are aware, is a real and present danger to any technology platform. And hospitals over the past year, it's been in the news, have not been isolated from that. So our concern is, and we're working in very close collaboration with our IT, networking, and security teams to develop cybersecurity protocols. The network has been what they refer to as hardened, which means that it's very difficult to infiltrate. But what we brought to the attention, and they were aware of it to some degree, but what we're shining a light on now is that medical devices more and more are being networked. So if the medical device itself has a vulnerability, that could provide someone the ability to get into our network through hacking or even to manipulate the device itself. And that's something we certainly don't want to have, where the FDA has produced some guidance on it and some directions which will ultimately turn into mandates of collaboration between vendors for new products and also existing products, and how to ensure that the older products and older operating systems are just as cyber secure as the new products. The other thing that we are working on is real-time tracking technology. This was known as radio frequency ID tagging or real-time location tracking system, RTLS. It's basically LoJack for mobile devices, starting with medical devices, but it has application for many other things within healthcare. You know, patients that are at a fall risk or at any other risk, and you want to keep track, you want to make sure they're not sitting up in bed. Things like that. Even visitor tracking can be done with that. But for our purposes, tracking mobile equipment, if there is a device recall, which we get reports on weekly and daily internally, if it's of an emergent need, we need to get to that. We need to find those devices, and we need to find them immediately. And in the dawn of cybersecurity, time is going to be even more of the essence, because even if that device is not in use on a patient, so maybe not a threat under a recall at that very moment, it still could be linked to the network, and we need to get to it immediately. This will also give us the opportunity, coupled with our new system, to ensure that every site, both physician office and hospital, has the appropriate inventory of medical devices to perform their tasks at the highest census level of surges, eliminating surges and shortages, or transferring equipment to sites if there's too much at one site and not enough at another. Say there's an infusion pump, and there's excess infusion pumps at one location, and another site is about to purchase new infusion pumps. There's every reason to believe that we can transfer that out, and everyone is better off for it. What we also want to do is to be able to create an equipment depot, a centralized area, like we do for our supplies. that would be available in a disaster, such as Hurricane Sandy a few years ago. We'd be able to deploy additional physiological monitors, additional pumps, additional high-end ventilators, life support equipment at a moment's notice. And also, again, with the reporting, future capital investment and investment planning, ongoing decision support. And for our purposes, in continuous process improvement, we endeavor to continuously enhance the technical training of all of our biomedical engineers and resources. That's training that's independent of or in partnership with our vendor partners and manufacturers. So in closing, what I'd like to say is that if you're interested in the fields of electrical engineering, IT, network engineering, if you are mechanically inclined, enjoy working with your hands, biomedical engineering continues to be a growing division. We heard research speak earlier of their accomplishments. There are also biomedical devices that are used, obviously, in research. Everything from microscopes to centrifuges and anything that they would be using to replicate what could happen in the real world. So once again, this blends a lot of different things, and if you take our role into capability, it not only blends the mechanical and electrical engineering with IT systems and networking, but also business management and decision making. So again, if you're interested in such things, you could do work to explore a career in biomedical engineering. You can advance the slide. That's all I have in terms of presentation, but I'm happy to take any questions anyone may have.
We do have a question. What are the most important skills needed to work in this field?
I'm going to turn that over to Mark. I have an idea, but I'd like you to hear it from the experts' mouth themselves. All right. The most important skills, well, obviously you're going to need to have electrical experience. You're going to need to know how electronics work, how it integrates into the clinical system, be able to work with the nurses. There isn't really one most important skill. You have to have the people skills. You need to be able to think on your feet. You need to be able to collaborate with clinical people, with other engineers. It's pretty much the whole gamut. So if I was just to add to that, what Mark hit upon is, the critical thinking and, of course, people skills and patience. You have to understand that quite often if a very important medical device goes down, heaven forbid, in the middle of a procedure, the physician and nurses, they're at a high anxiety level. So they're looking towards you to correct the problem and correct it immediately, and sometimes that's not the case. Things can get heated at times. You have to recognize that it's never personal, and our people do an excellent job of doing that. You just inform them what needs to be done, and in a well-oiled machine, so to speak, or to use an analogy, we will ensure that there are backup resources and devices to step in so that no harm is ever even part of the equation.
We have another question. What are some of the entry-level jobs that you have in your area?
Entry-level jobs begin at what is called the BMET 1, or that Biomedical Engineering Technician 1. And essentially, what's required for that is training and certification in electrical engineering. Really just to get your foot in the door. Most everything else you would learn from that point going forward. Again, as I mentioned, we're continually, either through vendors, when we purchase devices, we get training credits, or we send individuals themselves. And if I could just say, the opportunities are limitless. Maybe that's a little cliche, but it's as limited as much as your ambition is, because if you show an interest in a particular area, such as maybe ultrasound device or diagnostic imaging device, we will expend the resources to ensure that you're educated and certified on those devices so that you can go out into the field and you can master those devices, you can repair those devices, and you can train your colleagues how to work on those devices as well. So it starts at an entry level, at that biomedical engineering technician. Biomedical engineering technician tier 2 generally deals with a little bit more higher end devices, but not necessarily the true high-end biomed like life support equipment. And then your biomedical engineering technician level 3 can handle the entire spectrum that works on your critical care devices or your high-risk devices. As I mentioned earlier, diagnostic imaging specialists are exactly that. They specialize in that separate class of biomedical engineering devices or clinical devices that provide internal imaging, either real-time imaging or anything from X-rays to MRIs and beyond, for minimally invasive procedures. And again, it's a continuous learning curve because as medical procedures enhance and increase, either through new techniques or new devices, we have to make sure that we can support those devices.
Well, thank you so much to both John and Mark for your insights and really informative presentations. We very much like to thank all of our esteemed presenters for their time, insight, and expertise. We hope that you have found this to be informative and enlightening. We will be planning additional webinars in the coming year, and we wish you all the very best for happy and healthy holidays. Thank you and goodbye.